our 3D unit, we really only talked about we talked about nets, and we've kind of named and we've done some vocabulary with faces and bases and lateral edge and slant height and that kind of thing. You definitely need your formula sheet, so if you don't have that, you can put your strand 1 back in your SOL binder. That's totally fine. We'll pick that up next flex. But you really do need your formula sheet. So I'm going to grab one here, make sure I have enough for everybody. Anybody need a formula sheet? We should all have one in our binders. Pretty accessible here. But we're going to be using those formulas that you see on your formula sheet quite a bit today. So as you're looking at your formula sheet, I want you to look and see what abbreviation do they use for the lateral area and the surface area, and the volume for that matter. So if you look at these particular formulas, you should see an abbreviation. Which one was abbreviated for lateral area? LA. And what surface area? Is it SA or SA? Okay? So we're going to be looking at those particular areas today. We're going to make sure we know what a lateral area is, and we're going to look at some real-world problems with it. And then we're going to look at surface area and look at some real-world problems with that as well. I doubt we'll get to volume today, okay? But that's our plan. So let's start with making sure we understand what a lateral area is. It is a kind of surface area. It is part of the entire surface area, but it's missing a couple of things, okay? So let's drag, I'm not even sure what we're doing here. Oh, sorry. Okay. Oh, those are bases. I'm sorry. I'm trying to figure out what we're doing here. If you look at these particular shapes, I've got a cylinder and what's the blue figure? Let me turn it lights down so we can see the dotted lines. What's the blue figure? Be more specific. Square pyramid. Okay, so we want to make sure, because we name pyramids and prisms by their bases, right? I'm going to put this away for me so I don't have to take it. Thank you. So we're going to name it with the square pyramid, okay? So when we're talking about lateral area, it's all the area except for the bases. So which, in the green cylinder, which one of these shapes of the net would be part of the lateral area? The rectangle, the circles? Just the rectangle, okay? So that is going to be just the lateral area. That's the portion of the lateral area we'd be using. These are actually bases, right? If you look over here for the square pyramid, would it be the rectangle or would it be the triangles? That would be part of the lateral area. Just the triangles. And there are 4 of them, would you agree? And they are going to be. So if you look at your formula sheet, I would never am going to ask you to memorize these formulas. You'll always be allowed to use your formula sheet. So let's write what the lateral area is for each of these. Okay, so tell me what you think. What is the lateral area for a cylinder? What does the formula say?
2 pi r.
2 pi rh. We got to make sure we know what each of those things represent. Pi we know, 3.14 approximately. What's r? The radius of the base. Even though we're not using the base, we still want to use its radius. And then the height of the entire figure. Okay? Over here on lateral area for the square pyramid, what's the formula? I'm sorry? 0.5 LP. That's okay. I'm just making sure we're looking at the right thing. Okay, so we have to figure out what these are. So 1/2 L lowercase p. What's L? Slant height. So it's going to literally be, it's going to be this right here, is it not? That's the slant height. Because in a pyramid, it's slanted. They go to the vertex, and it's the height of the triangle. Okay, so we'll just kind of draw that face separately. What's lowercase p? I think there's a guide at the bottom that might help you on your formula sheet. What does lowercase p stand for? Perimeter of the base. It should say that at the bottom, does it not? It doesn't? Really? Oh, it doesn't. It gives you everything but. It doesn't tell you what lowercase p is. Interesting. There's a space and it should be there. Do you see that underneath there where it says abbreviations? It's kind of missing. I wonder if this is like an older version or something. I'll look at the newer version and see if it's listed so you don't have to remember it. But that's interesting that this particular version didn't have it on there. But that does mean the perimeter of the base, the lowercase p. So we would, in fact, be going around and finding that perimeter. Okay? So let's go ahead and use some of our information, and let's find a lateral area. Okay? So what kind of a figure is drawn up here? Okay, is it pentagonal, pentagonal? I don't really know. Tomato, tomato, right? So the base is a pentagon. Would you agree? Okay. So we want to be able to add some information. So I'm asking us to drag some of these values. They move around, and I want us to think about which ones are we going to use to label the values of our pyramid. So if we're trying to find, well, first of all, the formula that we're going to use is what? Let's identify that one. Look at your formula sheet. What's the formula that I'm going to use for the lateral area of any kind of 1/2 LP, right? 1/2 slant height times the perimeter of the base. So what values am I going to use? Well, I'm given the perimeter of the base, and I'm given the slant height, sort of. 3 is not the slant height. Would you agree with that? I'm given some information to help me find the slant height. So if the perimeter is 60 and it's regular, what does regular mean again? All sides are congruent. So what's the measure of one side? 36? Where'd you get 12, Lucia? So each side should be the same. So we're going to go ahead, and 60 divided by 5 is 12. So we know that one side of the base is 12. Matter of fact, any side of the base is 12, right? Okay. So I know I'm going to use that maybe. We're going to drag it. What is the slant height is 3 times the length of one side? What? Where'd you get that number from? Okay, so I'm going to put 36, but it's going to be hard for me to draw it. I'm going to draw it in separately. Can I draw it in like this? Would that be okay? So so 36 would be that particular slant height. So what we want to do is we want to write the formula. So 1/2, the lateral area is 1/2 times what two things? So 36 times 60. Good. And what do you get? 1,080? What units am I talking about? Nope. It's an area, right? So area means we're going to be squaring our units, okay? Square feet. I know, right? I agree. Feet squared. It's square feet is the way it's said, though. You're right. All right, so let's go ahead and look at a situation where we could apply it, okay? And this is one you should probably put in your notes. This is the tougher one. This is one that you're going to have to think a little bit. And I want you to talk to the people at your table about this problem. And I want us to figure out how many labels I can make based on this situation with as much paper as I possibly have. Okay? So you want to write this problem down. We're talking about lateral area. Today is April 29th. And I'm given a certain amount of paper, and I'm told how big the cans are. How many labels can I make? First of all, why is this a lateral area problem? Think about soup cans and labels and things like that. They go around the lateral area. They don't include you don't have labels on the top and the bottom on most cans. The one problem I have with this picture is if I was to actually take a soup can label off without ripping it, what do you notice? Don't they actually overlap? Would you agree? To glue it together? We're going to assume that they don't overlap. Okay, we're going to assume that there's no overlap and they're glued right to the can. Do you know what I'm talking about when I say that? Sometimes, most of the time they just overlap and slide right on the thing. You know what I'm talking about? We're going to assume that they're just exactly perfect on the can. Okay? It's a little bit different situation. So write it down. Think about how we could answer the length and the width of a can label and how we would use that to answer the question. Notice I have everything's in inches. So that's important to make sure that you're in the same unit. So I'm going to pull it for a hint and see what the hint is that this is going to give us here. Imagine peeling the label off the can. I kind of did that demonstration with the toilet paper. The shape of the label is a rectangle, and we would know how to find it. So the hint's really kind of what I already told you with toilet paper, right? So we kind of already know. I think most of us have an answer for part A. Okay? What is the height or the width of this rectangle? It's 6 inches. We'll just assume all of our answers are in inches right now. And then what would the length be? 4 pi. It's 2 pi r because it's the circumference. R is 2. So the circumference is 2 pi r or 4 pi. I agree with that. Very good. So now what we want to do, and 4 pi is approximately, what? 12.56? Ooh, 12.57. Okay. We're going to use the pi button's more exact. All right, so we want to figure out that's how long it is. And we have a piece of paper that is 45 feet long and 40. We should probably convert 45 feet to inches, don't you think? Make sure we're all in the same unit. So how many inches are in 45 feet? 540? So we have 540 inches. That's how long it is. So how many 12.57s fit? If I'm going to arrange my labels in the lengthwise, how many will fit? Do you see the questions I'm asking you? All right, I'm going to pause for another minute. I want you to answer those. All right, so I'm going to see if they have the same solution as what I would have. I'm not sure if they do. Ooh, that's fun. All right, I'm going to have to erase a bunch of stuff. I'm unhappy about that. All right, well, let's see if we can read through it. Oh, dear baby Jesus. All right, 270 is what they got. Let's see. Okay, let's do it. Well, I'll show you what they did. They did it if they did it vertically or if they did them horizontally. So they arranged them in 2 different ways. Okay, if you did it, they got 252 if you arranged them a certain way, and if you arranged them the other way, you got 270. 270 is the correct answer because that's the max number of labels, so nobody's right actually. Okay, depends on how you orient them. If you did it the way that most of us did, let me show you what I mean. Okay, so if we took our piece of paper and we said that this was, I don't know, how many was it? 500 and what? 540? So this is 540 and this was 40, right? And we said, okay, 12, how many 12.57s? So this would be 6 inches high. And we had to figure out how many 12.57s would fit in there. Does that make sense what I'm saying? So how many did y'all get? When you divided 540 by 4 pi. Okay, be careful. You didn't get exactly that. So 540 divided by 2 pi. Oh, is it 540? Oh, that's the problem. Thank you. Okay, 4 pi. All right, so we got 42.97. Now, I love what Deshay said. She's like, it's got to be 42. Why'd you say that? Why can't we round up? Because you would have part of your label missing, right? You don't want 0.97 of a label. You don't want it to say Campbell's Soup. You got to have the p, right? You got to have everything part of there. So I agree. So you have to say that that's 42. So we know right away that there's going to be a whole bunch of this empty space. Would you agree? Almost a label down there, but not quite. But this we had 42 labels in this particular row. Would you agree with that? And then we could go, how many rows tall could we go to get to 40?
I mean,
6 tall, okay? If we went 6 tall, we would still have some empty space up here. We'd have an extra 4 inches. Would you agree? There'd be 4 inches up here because we go up to 36 to get to 40. So we'd have, how many rows were there? I'm sorry, total of 6 rows. So 1, 2, 3, 4, 5, 6. Pretend like those are nice and pretty and even. Okay? So do you see why drawing it sometimes is helpful? You have all this extra wasted space on everything. But if I had 42 labels times 6, 42 times 6 is how you got 252. Okay? But you have some wasted space on the edges with that. Do you agree? So what they suggested is to orient them the other direction and go down this way. And you would have less empty space. And you'd actually get more labels in that way too. And that's why the answer, the best answer is the other one, which was, let me pull it out now for the, see if it'll let me. There we go. The best answer, if we, maybe, let's try again. The best answer is if we cut them horizontally, we go the other way, the other direction, and we'd have 270. Okay? Any questions about that? So it's kind of a thinking problem, don't you think? It's how do we use surface area, lateral area, not surface area, to answer a particular question. Okay, let's go ahead and extend our thoughts and let's look at surface area now. What's the difference between surface area and lateral area? We know what lateral area is. It's the distance around, not including the bases. So look at your formula sheet. What do you notice about lateral area? I'm sorry, what do you notice about surface area? It includes the bases, doesn't it? So we're going to find the lateral area and then just add however many bases we have. That's the total surface area. Okay? So we want to think about all of their parts, both the lateral area and the bases. So in a cylinder, you're going to find the lateral area and then you have 2 bases to contend with. Do you agree? Look at the surface area formula for a cylinder. You should see that. Do you? That simply means that you're still going to find the lateral area like we did before, but I have a top and a bottom to contend with. What about with the square pyramid? What is the surface area going to be in this case? Well, it's going to be the lateral area that we found, but how many bases does a pyramid have? 1. So what does the capital B stand for in each of these cases? Area of the base. I think it says that there too. That should be one that's included. P was supposed to be. But this does mean area of the base. Now, we do know that the base could be a pentagon. It could be a circle. It could be a lot of different shapes, right? So we have to remember we're going to have to take what we learned about area of regular polygons, dividing them up into triangles. Remember all that from a couple weeks ago? That's going to come back to us now, okay, when we find surface area. So let's look at a difficult case. What kind of a shape is this? I would write this underneath your problem that we looked at with the soup can labels and write this problem down as well. Okay, so we have a total surface area of a more difficult shape. So I'm going to pause the recording while you guys write it down for me. If I want to find the surface area of a prism, if I look at my formula sheet, I do not see anything with a pentagon. Do you? So what formula do I use? Any prism at all would use the same formula. So the one that Marvin just mentioned is the same one you'd use. It's the third one over in the top row. So find your formula sheet. Third one over in the top row is a prism. even though it's not a pentagon, it's still a prism. So we're still going to use this formula here, okay? So you still have to identify the correct formula. And if you look at the surface area for any prism, it's the lateral area plus the area of 2 of the bases. Okay? So let's start with the lateral area. What's the formula for the lateral area? And the lateral area of a prism is just the height times the perimeter of the base, and then we'll say 2 times the area of the base. Okay? So we need to find some information, don't we? Are we told any of it? Well, we're told the perimeter is 40. Would you agree? We're told that. All right, so let's put a 40 into my formula. I still need to find the area of the base, and I still need to find the height. I think they mean by length is the same thing as height. I think that's what they mean. Okay? So let's just change this word to be a height. I really think they mean the same thing.
Don't they mean like radius? Because it doesn't make much sense.
No, I think they mean the length. Okay? So if the perimeter around the pentagon is 40, what's the length of one of the sides? Nope, not 10. Pentagon is 5 sides. 8, right? So I know one of the sides is going to be 8. Agreed? All right. 1/4 the distance around the pentagon. Well, that's the perimeter, isn't it? So the perimeter is 40. What's 1/4 of 40? 10. Okay? So 1/4 of 40 is, so that just means that the distance between my 2 bases, or the height, is 10. Okay, that's what they mean here. So how does that help me find any of the 2 missing pieces that I need? Well, I need the height, don't I? So I need that 10, so we're going to put that 10 in there. I'm still missing this area of the base. So oftentimes we'll have to draw it separately. So let's do that. Let's draw a regular pentagon, and let's find its area. I know that one side is 8. That's all I know. How do I find its area? Do we remember? Got to divide it up into triangles. So let's do that. How many triangles will there be? If it's regular, there should be 5 congruent triangles. We're going to be looking at just one of them. So I'm going to draw a little bigger. Why am I drawing that in? Got to find the area of the triangle. So it's 1/2 base times height. I need to find the height of the triangle. How do I do that? I need to find this number. I need to find that height. How did I do that before? I find the top angle. Okay, so 360 divided by 5, how many is that? 72. So this entire angle is 72 degrees, but I don't want the entire one, I want half of it. So what's this angle right here? 36 degrees. That's no 30, 60, 90 triangle. I can't use special rights. Trig. I need to use, do you see how the worlds are just colliding? I have to find area. I had to use right triangles. I'm going to have to use trig now just to find the surface area of this shape. Good grief. Okay, so which trig? If you needed to find the area of this shape. Okay. Well, if you wanted to create something in this particular shape, you'd need to know how many of them to create. You need to find the area to be able to do that. All right. We'll call this H for the height of the triangle. Well, actually, let's do that. We don't want to label it H. Let's just label it X. Which trig function am I going to use? Sine, cosine, or tangent? Nope. Oh, yeah, it is the tangent. I'm sorry. It is a tangent. I'll draw it over here separately in case we can't see. So if I'm going to draw this right triangle over here, I'm trying to find the height of it. I know the base is 4. How'd I go from 8 to 4, by the way? Deshay, up here. How'd I go from 8 to 4? Half. Good. I know this angle is 36 degrees. When we did trig, how did we label our sides? Do you remember with respect to our angle? OH and A. Maddie, tell me what 4 is. Is it OH or A? With respect to 36 degrees. Okay. That's right. The hypotenuse is H. We don't need that information because that's not labeled. But the 4 is the one that's opposite. So it's O. It's across from the 36 degrees. X would be the adjacent side. Okay? So we're labeled with, we have O and A. And if we remember, SOHCAHTOA, which trig function am I going to use? Tangent. So we're going to say that the tangent of my angle is equal to the opposite over the adjacent. Gosh, Miss Mackert. The X is on the bottom. How do I solve this algebraically for X? Do we remember this from a while ago? Multiply both sides by X, divide by the tangent of 36. X is going to be 4 divided by the tangent of 36. What mode had your calculator better be in? And I can't tell you that on the day of the SOL. So we got to practice it. I really can't. Let's go over it. Go to mode. And mine's set in degrees. But if I reset any of your calculators recently, and oh, by the way, I have to reset them before the SOL. So guess what your calculator will not be in when you take the SOL? Degree mode, right? It automatically will be in radian mode. I have to reset it before because it's the law of the state of Virginia. And you know how those Georgia teachers went to prison? I'm not going to prison. I'm not cheating for you. You're going to take the test on your own.
Would they ever ask for radian?
No, not in this class. Always degrees. Okay? So we're in degree mode, so we're good. So we're going to go ahead and just double check. So we're going to say 4 divided by the tangent of 36. We're in the right mode, so about 5.5. Again, what is that number? The height of the triangle. So that's going to be 5.5 is here. How many of those triangles did I have for the whole pentagon? 5 of them. So the area of the base is going to be 1/2 times 8 times 5 times 5.5. So I got 110.11. Did you guys get that? For the area of the base? That's just one of the bases. And again, it's centimeters squared, but we'll get to that. I have 2 of them, don't I? Whew, okay. So let's go back up to my formula, and I'm going to plug in up here 110.11. All right, so 110.11. So I'm going to multiply that times 2, and then add 400. So the entire surface area of this pentagonal prism is 620.22 square centimeters. That's about as tough as they're going to get. Okay, we started with a hard problem because I wanted to make sure that if you can do the hard ones, you can do the easy ones. Okay, so I have some problems for us to work on. in class. You have a separate homework assignment, so please understand that. But if you look at this, you're going to open it up in your packet here that I'm about to give you. It's called a 3D packet because it's three-dimensional stuff. And I want you to look at the page that has these problems on it. I believe it's the very first page that you guys come to. I've gone ahead and identified the formulas that you'll need to do for each of these two problems. It's a good idea, and I want you to write the formula down that you're using. If you notice, the surface area of a rectangular prism looks a little different than the others, because you can really pick any two parallel sides to be the bases. It doesn't matter which ones you pick. So that's why we have its own formula. There's two sets of each of the opposite sides, right? There's actually three pairs of parallel sides, top and bottom, left and right, front and back, right? So that's why you have two of each, 2 times, because there's two of each of those sides, or yeah, each of those faces. So we have to just pick one to be the length, the width, and the height. It doesn't matter which ones we identify to be the length, the width, and the height. I'm just going to pick length, width, height, but it really doesn't matter, okay? So we're just simply going to say 2 times 30 times 15 plus 2 times 30 times 10 plus 2 times 15 times 10. And what's the total surface area going to be in this case? 3,800? 1,800. And what would the units be? Centimeters squared. Okay? So that's the units we're using. But that's the work for it. What's different about the surface area formula that I picked for the prism than what's on your formula sheet? Anybody? What's different? It's not the same one that's on your sheet. What did I do? I substituted the lateral area already in it. Is that okay? The lateral area is the height times the perimeter of the base. So I just plugged it in to make it one thing. What number up here represents the height? No. The height of a prism is the distance between the two bases. So that's why sometimes it's a good idea to highlight the two bases. Darken them in. The distance between those two things is called the height. So the height in this case is actually 16. Are we okay with that? It just, rather than being, it's just turned on its side, that's all. Okay? It's just that h represents the distance between the two bases, The perimeter of the base, so if we've identified the triangle as being the base, how do I find the perimeter of it? Pythagorean theorem. Good. So I've got to figure out what that hypotenuse is. 5 squared plus 12 squared is equal to c squared. What'd you get? 13. Maybe 5, 12, 13 is a common one that you know. If it is, that's great. So what's the perimeter of my base now? 30. If I add up all those, I get 30. So that will be the lateral area. Now I need to find the area of the base. What's the area? 1/2 base times height, and it's just of the triangle now, right? Just the triangle. So we have 1/2. The base of the triangle only is 5, and then the height of the triangle only is 12. So if we multiply all that together, what's the entire surface area in this case? Exactly? So I got several different answers. Let me see what I get. So I got 540 square inches. Remember, area, we have square inches. Okay? So I'm going to give you the rest of class today, and you're going to finish all by next class, problems 3, 4, 5, and 6 on here. And then on the next page, you have a little puzzle to work on. Okay? Now, not all of these are lateral areas or surface areas, but it says the area in the code below. It says the total area, so we're only going to be working with surface areas here. Some of them are two-dimensional figures. Some of them are three-dimensional figures. But you can use your formula sheet. You want to match them up with whatever you see here, okay? But we are looking for total surface areas in these cases. So both of these will be due. You need to show me your work. Don't, with this puzzle page especially, because you have some answers to choose from, don't come without any work shown, okay? So I need to see, just like we did here, what numbers we chose and why, so we can get full credit on our work, okay? So I'm going to give you the rest of time. If you would like to take your formula sheet out of your SOL binder, that's fine. Just make sure you return it next class so you can use it for your homework. Fair enough? Okay.